Good morning, all. I would like to start by introducing myself. I am Sait. I work at GEMS Education Dubai. So I work as the head of AI. I look after the AI initiatives across the driving around the GEMS Education schools, more than 200 schools all over the world. So I take the initiatives to the schools. I've been working on AI, machine learning, and deep learning for more than 10 years. I've been in the industry for close to 18 years now. I've been lucky to work at the forefront of AI, and it's a great time to be involved in AI with huge leaps in AI coming into the forefront of the public with tools like GPT and ChatGPT, etc. And also I've been developing and deploying solutions specific for education using AI for quite a lot of time now. My background is mostly on the research side on machine learning and deep learning. I also have 17 US patents around AI and machine learning. I look after the initiatives where we use AI in order to personalize education, in order to drive a better learning and teaching outcomes, develop solutions for students and teachers in order to help the students learn better, in order to help the teachers to teach better. So apart from my work, I'm also an avid chess enthusiast. I've been following chess very closely for close to 10 years now, and even developed AI chess engines using models like GPT and ChatGPT. So we will delve a little deeper into those issues today. So also wanted to bring into the dynamic intersection of AI, chess, and classroom in my talk today. So let's start with looking at why AI is required in chess. Why can't we just write an algorithm and can solve the chess or can always find the best move possible? Why it's not possible? So the problem in chess is the number of possible moves. It increases exponentially. Just after 4 moves on the chessboard, the number of possible positions becomes around 228 billion. And for a complete chess game, the total number of possible moves or the total number of possible positions is more than the number of atoms in the universe. So you can see that it's not computationally possible in order to for a computer to go and evaluate all the different positions and find what's the best move and then solve the chess engine completely. So that's why we have to use AI, which is kind of like imitating human intelligence, where instead of looking at all the different positions, what is the best approach, or what is the best with the limited computation that we can do. That's why AI can work really well. So traditionally there have been 2 different types of chess engines, the type A and type B as they call. So type A is more like a brute force search solution, where it looks at all the possible positions but only up to a given depth. So it is actually using the horsepower of the computer in order to evaluate much faster than a human could do, and then finding the best move possible. There's a type B kind of solution where instead of checking all the different possibilities, it comes up with an intuitive search. It always looks for it always identifies what are the best possible variations at any possible time, and then only goes down on those paths. So we look at a couple of solutions which fall into these categories. So the first major breakthrough in AI in chess came in around 1997, which was with Deep Blue. So it was the first AI program to beat a world champion in chess. So it was built by IBM, and also to see how it works, right? So it was a custom-built supercomputer. So it falls into the category of type A, where it uses brute force in order to identify the best possible move, but by going down different variations possible at any point in time, but only up to a given depth. So but with just the horsepower that the computer had, it was able to do a much better job than a world champion and was able to beat Kasparov. So that was a game-changing moment in AI. That was the first time AI could actually beat a world champion, and it actually gave a path for most of the chess engines to follow. But there were certain limitations for the type A or the deep blue kind of chess engines. So it could not learn anything new or could not form or adapt to new strategies as the game progressed. And it was a custom-built solution for chess, and it could not be, it's not something which is transferable to other domains. And also, it had a lot of rules which were provided by the human experts, and it could never grow beyond the intelligence of the creators of the chess engine. So let's look at how in the future it changed. So when we come to the next the major breakthrough for AI in chess, that came around 2017, and that happened with AlphaZero. So AlphaZero was an algorithm which was developed by DeepMind, which was acquired by Google. So it was completely a drastic change in how chess engines worked. So AlphaZero was programmed only with the basic rules of the chess, and it was not given any other information. And it learned to the openings, learned strategies by playing against itself. So you can see the graphic on this slide, where you can see that by learning against its or playing against itself, it has actually gone much beyond the other chess engines, or how with just close to some 4,000 steps or 4,000 games, it was able to beat the best chess engine available at that point of time, which was Stockfish. So this is unlike any other chess algorithms which existed till then. And it actually, it had a lot of peculiar features, like it had very the human-like playing nature, and it used to go for sacrificing materials for long-term advantage, etc. And certain other important aspects of this solution was that this was more like a generic approach, where the same algorithm or the same approach or the same framework could be applied for other games as well. The same approach worked for other board games as well, and it has excelled in almost all the board games that it has been asked to play. So it demonstrates how AI can be used, transform in various domains, and how it can go beyond the human understanding or the intelligence of the ones who have created those solutions. So this is actually a very interesting point, because we are also right now at a similar phase when we look at chess. Instead of chess engines, it's more traditional AI solutions like ChatGPT. So what we are seeing today is like there was a huge hype when the tools like ChatGPT were introduced to the general public, and there was a big hype around like it's going to take away all the jobs, and there's going to be a computer uprising, etc. But what we are seeing now is that people have become more realistic about what the tools like ChatGPT can do. And it's kind of what's limiting today, what's being limited by is the knowledge that it is trained with, and because it is trained with only the human data that it is getting from the internet, it is limited by that. So how we can draw some parallels between AlphaZero and the ChatGPT. It's like ChatGPT today, I would say it's more like how Deep Blue was. It is trained on specific kind of data. It is limited by that, and what could change further is kind of like a paradigm shift can come if you look at the approach like AlphaZero. If let's say OpenAI or some other company is able to crack that or have a generic approach, then it can go beyond a human understanding, and ChatGPT kind of tools will be able to do things which a human could not envision, which is not possible today. So now that we have taken a look at the AI, let's see how the AI is being used in the modern education. So like I said before, I've been leading the AI initiatives at GEMS Education. So we develop a lot of AI solutions which are looking at enhancing the learning outcomes of students. We are able to develop personalized learning paths for the student, because we have a comprehensive data around the student a profile, we have we have a 360-degree view of the student. With that, we are able to build a consolidated profile for the student and also personalize any assessments or any learning content that each student might. It's tailored to each student's capabilities. Also enabling adaptive assessments, and the teachers are able to use AI solutions in order to teach better. AI is making their jobs easier by creating assessments automatically from any content. We are also developing solutions which can enhance interactive learning, because AI has the capability to connect with students all around the world and bring them all to a single platform where they can interact and learn together. Sorry. Okay. So now to look at the synergy between chess and AI. So what the chess does better, it's actually building the strategy thinking in students. And where AI excels better is the problem-solving abilities of the algorithms. So if we have to bring them together, or if we are able to build a solution which can which harmonizes both chess and AI, what it actually can do is that it can actually enhance the strategic thinking of the students and also enable the problem-solving skills of the students by using AI-generated problems, which can be solved using chess. And also, as you already know, that there are a lot of enhancements or a lot of advantages of introducing chess for students, where their cognitive and emotional intelligence can grow really well. And if you embed AI into that, where we can personalize for each student how the chess puzzles of the chess lessons, how it needs to be delivered for each student to make it more engaging and as well as more effective for each student, then it can really do wonders for students. Improved decision makings and interactive integrated learning platforms, where we can actually merge the chess into the learning curriculum itself and look at it as a way of building problem-solving skills in students rather than as a game. So that's where the AI can really help, where it can actually bring the problem-solving skills, build or deliver very personalized problems or quizzes for students in order to help them learn better. So for the future prospects, what we should be looking at is an education model where we can infuse the synergies between chess and AI seamlessly. So there are different ways in which we are planning to adapt to that. So we are looking at the effective learning outcomes. So what we can do with chess is, or AI is, we can actually pinpoint with very high accuracy the effectiveness or the level of each student, where they are doing, how they are doing in academics, or let it be even in chess. So given that level of sophistication, if we can merge the chess and AI together, it can also enable in actually quantifying how well the cognitive skills of students and how well their resilience is growing with inclusion. And also the inclusive adaptabilities of chess or of AI. So with AI, we can actually ensure that the content or the lessons that are given to each student is tailored to their capabilities, make it accessible to each student, which is not possible in a group environment where a teacher has to look after tens of students, whereas an AI is actually dedicated to each student and tailored for their capabilities. So further, what we need to look at is the implementation strategies for how to include AI and chess in education. So what we are looking at right now is actually incorporating AI with the personalized learning, and also ensuring that the curriculum is actually inclusive of all the things that we talked about. It also requires a technological infrastructure where the teachers are trained and also the right amount of AI hardware and the software is actually deployed in each schools. And also what we need to do is a continuous evaluation and adaptation of the changes that we bring about in curriculum, or it could be the assessments or the learning content that a student should be using. So, as a closing thoughts, we talked about the synergies between chess and AI and how it can be really used to transform the paradigm within classrooms. What we need to do further is to take this dialogue forward in order to ensure that it just doesn't stay as research papers or as a small projects, but it can be rolled out as a nationwide initiative. To close, I would like to thank the Judit Polgar Foundation and the Global Chess Festival organizers for this opportunity. And it was great coming here and meeting with such dignitaries and having such enlightening discussions. Thank you.
Thank you very much, Shamit Sait. I think this has been extremely instructive. Now, as you have mentioned several times, the ChatGPT, given the rapid advancements and capabilities of AI models like ChatGPT, how do you foresee the educational landscape evolving?
Sure. So that's a very good question. And if you look at the education landscape, it has not really transformed drastically over the last 100 years, I would say. And what the tools like ChatGPT has done is kind of really upend this the paradigm. So what we are seeing today is the schools are really confused, how to introduce this, how the students should adopt these kind of solutions, how teachers, whether they should be allowed to use these solutions, etc. So it is kind of at a turning point as of now. But how I see it changing in the future is we are definitely going to embrace these technologies, and it is really going to change how the lessons are delivered, how students are doing assessments, how the learning itself is being done. So for example, there are certain schools who are who are apprehensive about whether the students should be using these tools. So how can they trust the homework the students are doing, whether it's being done by the students or ChatGPT? Mm-hmm. So it's very similar to let's say how the calculators were invented, and how that changed how math is being taught in schools. Mm-hmm. So it is kind of similar turning point as of now. So what the introduction of calculators, how it changed, it actually made the teaching of mathematics itself different. So it actually made the math more difficult for the students, so the students are able to do what the calculators couldn't. So that's similar to that. I would say that what the students are expected to do will change what ChatGPT can do, whether it's writing an article or something which is which it can do really well. The students should be do much more than that. Students should be able to, or students should be asked to do things like critique an output which is developed by ChatGPT and go beyond that. And also the teachers will be leveraging these kind of tools, and it can really help in making their education more personalized. Mm-hmm. So overall, I feel it's a very good positive change in the right direction.
I see. And as we are focusing on AI and education, could you share an instance where implementing an AI project in the educational environment posed unexpected challenges and how it was navigated?
Okay. So we had an interesting experience where when we developed a solution where we could actually detect students who need attention and in a proactive way, and help the teachers engage with them in an earlier phase. So as a technology solution, it was we felt it was very well thought out, and with the numbers that we got out of that was really promising. But when we deployed this in the classrooms, teachers were very apprehensive. They were not able to understand how a solution is coming up with or identifying certain students as requiring more attention, and whereas others not, and they were not able to accept that, and they were not able to come in terms with such a solution can pick patterns in students. But how we approached that issue was that we actually made the model or the AI solution much more explainable. We actually could explain to teachers certain parameters on how the model was predicting certain students, and that helped in certain teachers to understand, okay, this is how it is working and this is how it can help me to enable students learn better. So that was a challenging aspect of the solution, but we were able to overcome that.
Let me tell you something which I consider relevant. The Spanish Institute of Cybersecurity is looking for young talent among chess players. Why do you think they are doing that?
Yeah, so that's a very interesting question, because what I feel, there are a lot of parallels between cybersecurity and chess. So cybersecurity is a completely evolving space where it's always kind of like a cat and mouse game with the hackers, who always try to outsmart the cybersecurity professionals by inventing new strategies in order to deliver attacks. So there are the aspects of how do we work under pressure, how do we come up with innovative strategies, and always try to stay one step ahead of the wrong players, right? So that's exactly how the field of cybersecurity is, and I can really see the synergies between both the fields. So if a cybersecurity expert happens to be a chess player also, right, I can really see how he can actually transfer the skills he has learned in a game in order to work really well in his field.
And finally, a tricky question for a short answer, right? Suppose ChatGPT is here with us, and we ask, I don't know if I have to say him or her, anyway, what will be more instructive to introduce in the curriculum, chess or football? What do you think the answer will be?
So, knowing the ChatGPT and the way it is programmed to be neutral in all circumstances, I know the answer would be like pretty much like it would try to highlight the positives of both, and also try to highlight that required based on the environment and based on the scenario that you want to deploy, and you have to choose the solution wisely. So it will it should definitely point out things like the enhancement of cognitive abilities, perseverance due to chess, but also the importance of teamwork, and also the physical development that happens within football. So definitely will point out the best in both cases, and will ask you to choose what works best for your scenario.
Sait, a great expert on artificial intelligence and education. Thanks a lot. We have learned really a lot with you. Thank you. And if you want to know more about chess connections with artificial intelligence, coding, mathematics, etc., in a minute I'm going to interview another great expert, Agustin Weiss, who works as an engineering manager at Google Bard, a chatbot similar to ChatGPT. Agustin is also heavily involved in next-generation education around coding and mathematics.